So guys, let me bring you over to this. So the majority of this time is we're going to be talking about parallelograms because the stuff involving trapezoids is very brief. So we're going to spend a little more time talking about parallelograms. So like I said, guys, this document is on our calendar for today. The things like these bullet points that we're going to be talking about first, if you don't have a chance to write all this down right now, you can always pull up this document on our calendar and write some of this down later. Okay, so, but also keep in mind too, when you're taking notes, you don't have to write every single thing down. You can kind of shorthand some of this. So for example, here's what a parallelogram looks like. And of course, it's called a parallelogram because opposite sides are parallel. So the top is parallel to the bottom and the left side is parallel to the right side, right? It's like the main characteristic of a parallelogram. These guys are some of the main ideas that come up if you have a parallelogram. So for example, if it's a parallelogram, we know that opposite sides are congruent. And again, if you're writing all this down by hand, you don't have to write the whole thing. You might just say, just list some of the main ideas like opposite sides are congruent. So when these guys are parallelograms, we know things like, let me do this in red so it stands out a little better. We know opposite sides are parallel and congruent. So the top and the bottom would be equal in length, and the left and the right would be equal in length. So opposite sides are congruent. We also know that opposite angles are congruent. So for example, I don't want to mark this up too much or it's going to get confusing, but angle P would be congruent to angle R because those guys are opposite angles. We also know that angle S would be congruent to angle Q. These were supposed to be angle marks right here, but it didn't translate over well for some reason when I downloaded it. So I was supposed to say angle P is congruent to angle R, and angle S, angle Q. So all the opposites are equal. Opposite sides are equal, opposite angles are equal, all the opposites are equal. Here's the one that's a little different. Consecutive angles are supplementary. Guys, this goes back to something we did first semester when we had parallel lines, and we did things like, if you guys remember, alternate interior angles, alternate exterior angles. This goes right back to that idea. Because we have parallel lines, we know that consecutive angles are supplementary. So remember what supplementary means? It means they add to 180. And consecutive means that they are next to each other. So if you have two angles that are next to each other, then they add to 180. So for example, angle P and angle S would add to 180. Or you could say angle S plus angle R adds to 180. So if you take any two angles that are next to each other, they add to 180. So those are the three main properties. This one's kind of a side note that honestly you could have figured this out based on some of the things that we already talked about here. So what this one says is, if it has one right angle, then they're all right angles. So for example, if this happened to be 90 degrees, then they're all 90 degrees. But like I said, we really could have figured that out by these other two properties. Because if this is 90, well, we already know opposite angles are equal. So if this is 90, then this has to be 90 by that rule. We also know that consecutive angles add to 180. So if he's 90, then he has to be 90. So that they add to 180. So really that's something we could have figured out based on these two bullet points. But nonetheless, something worth mentioning, I guess. So let's go down to a couple examples of our own here. So do these with me. So we're going to jump over here to number 2. So let's talk about the two main properties that came up first. So, and it doesn't matter which of these letters you want to solve for first. I'm just going to start with the opposite sides. So one of the main properties we saw up there is that opposite sides are equal. So if this is 8y and this is 88, I know that those guys have to be equal to each other in order for this to be a parallelogram. So opposite sides are equal, and that's going to give us, all the equations that we're solving today are pretty basic, but this should give us a pretty easy equation to solve. If I divide both sides by 8, we get our value for y. So opposite sides are equal. The other thing we learned is opposite angles are equal, right? So if this is 90, and we know by the little mark right there that this is 90 degrees. So if that's 90, then this is also 90 degrees, right? Opposite angles are equal, so 6x is equal to 90. So if we divide both sides by 6, we got our value for x. Guys, at any time, feel free to stop and ask questions. If you have questions, let me know. So if I lose you or if I go too fast or anything like that, please let me know. All right, let's jump over here to number 3. So we're going to start with the obvious one on number 3. So if this is a parallelogram, automatically we know the property like we just did, opposite sides are equal. So I know 6x must equal 12. So opposite sides are equal. So if I divide by 6, we figure out that x is 2. So how do we solve for y? Because we don't know what's across from him. I mean, I see these marks. So what does that tell us? So if you see these all have that single congruent mark. So based on those marks, what they're trying to tell us is that in this shape, all 4 sides are equal, right? That's what those congruent marks mean. If they all have a single congruent mark, that means that all 4 of them are equal, which isn't always true. That's why they had to mark it for us. So in this one, if all 4 sides are equal, then that means 3y also equals 12. All right, so based on those marks, we know that these guys are also equal. So 3y is also equal to 12. So divide both sides by 3. We got our value for y. So if it doesn't fit one of the main bullet points that we talked about up above, then somehow they're going to give you more information so that you can solve it. All right, let's go over to number 4. So guys, if you look at this one, we got 2 rules at play. The first rule that might stand out to you, remember, we already know that opposite angles are equal. So we know that 3y is equal to 12x. The problem with that is I can't solve this equation because I have 2 different letters involved. So that means we're going to have to start with something else. All right, we're going to come back to this one in a second, but we can't solve it yet because I don't know x or y. I can't solve an equation with 2 different letters. So let's go back to where I see the same letter. So these are kind of the ones you want to pick on first. So notice these both have an x. So what's the relationship between those 2 angles? If you look back up at our 3rd bullet point, remember that consecutive angles are supplementary. So I know that 6x plus 12x equals 180. And that's an equation we can solve because it only contains x's. So let's do a little solving here. So if I add those together, that becomes 18x and if I divide both sides by 18, we figure out x is 10. So now let's go back to this one. Now we can solve this because now we know that x is 10. So because x is 10, I can put a 10 right there. And now we have an equation to solve. So if we clean up that right side, we know that 3y is equal to 120. Divide both sides by 3. We figure y is 40. So some of these, the order that you take will matter, right? We really couldn't solve for y first on that one. We needed to know x. Sometimes it matters, sometimes it doesn't. Let's jump it down to number 5 here. Guys, what you're seeing on number 5 is they obviously drew in a diagonal, right? So if they drew in this diagonal, it sort of makes the shape a little more unclear when I have diagonals involved. So what if we drew the shape without the diagonal? What would our numbers look like? I mean, this is still 5x. And this is still 2y. But what about this angle right here? So notice they gave it to us, but they gave it to us in pieces. Part of it is 60. The other part is 55. So if we ditch the diagonal, what is the total angle that really goes into this shape? So if I add those two together, we can see the angle as a whole is 115. And that's easier to work with because now it clearly fits our properties that we've been working on right now. So once you take out the diagonal, it really becomes exactly like what we just did on this one. I can't start here because I have two different letters. So let's start with something we can solve. Remember, consecutive angles add to 180. So I know that 115 plus 5x is equal to 180. You could have started here if you wanted, because this works too, right? These are also consecutive angles. So we could also say that 2y plus 115 equals 180. Once you solve for one of the letters, oftentimes you get several ways that you could then actually keep moving forward with it. I just picked one of the rules that was already laid out for us. I'm not going to solve those right now, guys, just in the interest of time. I know that you can solve those equations. We've already done a few. I want to jump over to number 6. Guys, see if you can take the first step on number 6 ahead of me. See which equation you would set up first. So I know opposite sides are equal, but I don't really want to start with these because they have two different letters. So let's start with the left and the right side. So opposite sides are equal, which means 30x is equal to 150. And if we divide both sides by 30, we figure x is 5. Guys, now that you know this is 5, now we can go after this scenario. So we do know that 2y is equal to 72x. Which initially we couldn't solve, but now that we know what x is, we can solve it. Right? So I'm going to replace my x with the 5. Now that we know that x is 5. So we did need to figure out what x was first, but now we can use it to figure out that y value. So if we multiply 72 times 5, we get 360. And divide both sides by 2. And we got our answer for y. So yeah, David, like I said a minute ago, I'm just trying to save some time here. I know you guys can solve these through, so I'm gonna let you solve those on your own. Guys, let me jump over to the back side. Before we talk about trapezoids, and like I said, trapezoids will be real short, there's really one more rule I need you to know about parallelograms. So the other rule I want you to know about is, you guys see the diagonals? So like DB is a diagonal and AC is a diagonal. So when you draw in the two diagonals of a parallelogram, they bisect each other. So you guys remember bisect means they cut each other in half. So when these diagonals both got drawn in, AC was cut in half. So this is equal to this, 2 equal parts, because it was cut perfectly in half. It also tells me that DB was cut in half. So that means this piece is equal to this piece. So when they got bisected, they got cut in half or into 2 equal parts. So let me jump down to a couple quick examples with you. We're going to look at 1, 2, and 4. So just based on that rule, guys, if you look at number 1, so as I look at the diagonals, again, remember these diagonals were bisected. So that means that 3x is equal to 12, right? This whole diagonal was cut in half into 2 equal parts. So 3x and 12 would have to be equal to each other. So if we divide, tells us x is 4. We also know that this diagonal was cut in half. So that means that 4y has to be equal to 8. All right, so that's the main rule on this. Let me give you 2 twists on this problem that you can run into, because sometimes it's not as straightforward. Well, guys, as I look at this one, again, I know that 4x is equal to this, but we don't know what this is. We don't have anything for that. So I can't start with 4x. So let's start with the one that we can solve, which is right here, right? So based on that same rule, I know that 2y is equal to 28. Since our diagonals were bisected. So if I divide both sides by 2, we figure out y is 14. And that makes sense, right? If I put a 14 right there, then 2 times 14 is 28. So we know that this is 28. We know this is 28. So look at these congruent marks. We ran into one of these earlier. Remember, those congruent marks are there to tell you that these 2 sides are equal. So if he's 28, then he's also 28. Now we can look at this and say, okay, 4x equals 28. And now we have something there to solve. So we get x is 7. All right, guys, let me take you down to number 4. Here's another twist on the problem. So you guys remember on, I think it was Friday, we did a little work with right triangles. As promised, right triangles never go away. So they're embedded within like every shape you can deal with pretty much. So you guys see on this one that the diagonals were perpendicular to each other. So they form this right angle right there. So you can see we actually have 4 right triangles on this problem. Let me start with the obvious one. Based on the rule that we just talked about up above, we already know that 3x is equal to 10, right? The diagonals were bisected. So then this equals this, so 3x equals 10. And so obviously we can divide both sides by 10, by 3. So we figure out that x is 10/3. But what about y? So guys, if you see right here, this is a little 30, 60, 90 triangle. So the only way to figure out y on this one would be to use your 30, 60, 90 rules. You don't have enough information to do anything else, right? So we would have to know our 30, 60, 90 pattern on this. So something we talked about on Friday, and I'm going to keep bringing these up constantly throughout this chapter so that we get a lot of practice with them. Here's my short leg is 10. Y is representing the long leg of that triangle. So think to yourself for a minute, how do we go from short leg to long leg? So the rule was we multiply by the square root of 3. So if my short leg was 10, then my long leg is 10 radical 3. So like I said, they don't all fit the direct bullet points of a parallelogram. They are going to take you back to some prior knowledge in solving some of this stuff. So that's why we're going to keep practicing with right triangles, because like I said, you're going to need them forever. You're going to keep coming back to that stuff for a long, long time to come. So guys, that was the highlights of parallelograms. Let me quickly go over, because this will be very brief, trapezoids. So this is the other shape we're going to work on this week. So parallelograms and trapezoids this week. It's going to be our focus for chapter 11. So guys, trapezoid looks like this. I'm sure you've seen it before. These get introduced in easily middle school math, so I'm sure you've seen this before. The main characteristic of what makes something a trapezoid is that you have one pair of opposite sides that are parallel. In a parallelogram, both pair of opposite sides are parallel. But it switches to a trapezoid when you only get one pair of sides that are parallel. So the two sides that are parallel, we call the bases. So this is a base and this is a base, and that's important to the formula we're going to be using later on this week. So base 1 and base 2, the parallel lines. The other two sides are called the legs, and sometimes those legs are equal. Not always, but they can be. If those two legs are equal, then we have ourselves an isosceles trapezoid. But that's only if the two legs are equal. Then it's isosceles. Guys, there are two rules that I want you to know on this shape. Like I said, this will be brief. And it's all involving the angles. No matter what kind of a trapezoid it is, whether it's isosceles or not, because these lines are parallel, we still get consecutive angles like these ones that add to 180. So the first rule, and you can write this down somewhere because I didn't say it on this, but I want you to know this, is that angle S and angle R would add to 180. And that would be true on this side as well. Angle T and angle U. So there's one of our rules. And that, again, that's for all trapezoids, whether it's isosceles or not. This rule is true all the time. The other rule is the one I underlined in red. This is the one that's only true if it's isosceles. So if it's isosceles, then the base angles are congruent and the diagonals are congruent. We're not going to spend time on diagonals of these right now. I just want to identify these base angles. Guys, the base angles are the ones that are connected to the same base. So if you look at R and U, those would be congruent base angles. And if you look at S and T, those would be congruent. So let me do this so that we remember the rule. So those are congruent. Those are congruent if it's isosceles. So let me show you this real quick here, and we'll call it a day. So let's just find some missing angles here. So we're just going to fill in all four angles. So the rule that we just talked about is if these are congruent, then the base angles are congruent. So if this is 125, this is 125. So how do we get the bottom two though? So that goes back to this rule. This is true about every trapezoid. Consecutive angles like A and C or like B and D would add to 180. So I know that, and I'll just write it out so you have it for your notes. I know that angle A plus angle C is 180. We know angle A is 125 degrees. So all I'm going to do is subtract 125 over, and that tells me the angle C would be 55. Guys, if you go back to those base angles, remember if these two legs are congruent, then not only are those base angles congruent to each other, but so are these. So if C is 55, then D is also 55. See how we're doing on time here. So guys, I know we're about at the end. We don't have to do number 2 right now. It's really very similar to number 1. There's really nothing new in that problem. It's just going to be extra practice. So guys, for today, I do want you to submit those notes.